So let's look at to the strength of acid and base. Okay, we know that the acid can be strong acid, weak acid. Same goes with base. It can be weak base or strong base. So the acidity or the basicity strength is actually depending on the extent of the dissociation of the acid and base in a reaction. Okay, so if we say that, or if we categorize an acid or base as a strong one, it means that they are the substance that completely ionize in water. They are 100% dissociate into ion. Okay, however, for the weak acid and weak base, they are the substance that partially dissociate in water. So this description of the strong acid, strong base, weak acid, weak base, as you have to be able to differentiate them and identify each. So strong acid include hydrohalic acid, HCl, HBr, HI, and then the strong acid can be oxo acid that contain oxygen atoms exceed the number of the ionizable proton. Okay, by 2 or more. For example, we have a nitric acid, H2SO4, HClO4. Okay, as for the weak acid, okay, it is include HF, the only hydrohalic that is weak. Okay, and then the acid in which H is not bonded to the oxygen or to the halogen, for example, HCN. Then weak acid can be oxo acid in which the number of oxygen equal or exceed the number of the ionizable protons by 1, for example, HClO, HNO2. And all the carboxylic acid with the general formula of the RCOOH, for example, CH3COOH, C6H5COOH, they are all weak acids. So it is easy for us to identify. As long as we found COOH, we know that they are weak acid. Other than that, okay, no choice, we have to memorize it. Then the category of the base, the strong base include the water-soluble compound that contain O2 minus or hydroxide ion. Okay, and the cation that usually those of the most active metal. Okay, the base that is formed by active metal, lithium, sodium, potassium, rubidium, cesium, and contain OH in their formula. As for the weak base, ammonia, amine with the general formula with the lone electron pair. Okay, if we have this example, we have HA. For example, we have 100 molecule of HA. Okay, when HA undergo dissociation, it will produce 100 ion of the H3O plus and 100 ion of the A minus. No more HA left after the dissociation. So that is the strong acid example. If let's say we have 100 molecules of the HCl, and we know that HCl is a strong acid, after HCl undergo dissociation, okay, we have no more HCl, we have H plus, Cl minus, and H2O. Okay, because HCl will be dissociated when it is dissolved in water. However, if we have a weak acid or weak base, for example, if we have 100 molecule of HA acid, after dissociation, we have a small amount of the H3O plus and A minus that is produced, and major of the HA remain as HA. It's slightly ionized into ion or partially ionized into ion. Okay, if we say we have HA undergo dissociation in water, we have example here acetic acid CH3COOH. Okay, after the dissociation occur, after the equilibrium achieved, we have H3O plus, we have CH3COO minus, and we still have CH3COOH remain in our reaction vessel. That's the difference between weak acid and strong acid. Same thing that is happened for strong base and weak base. So let's recap. The strong acid dissociate completely into ions in water. Okay, while the weak acid dissociate very slightly into ions in water, slightly or partially dissociated. Makes the Kc, remember the Kc, the equilibrium constant, less than 1. Okay, so let's look at to the acid dissociation constant. So we have this reaction Ha plus H2O produce H3O plus A minus. Look at to this reversible arrow means that okay, this is the reversible reaction. Okay, it can occur in a forward and also reverse direction. Okay, when we write the Kc expression of this reaction, it will be Kc equal to H3O plus, concentration of the H3O plus, multiply with the concentration of the A minus over concentration of the Ha. Okay, no H2O come out in our Kc expression because H2O is liquid. Okay, so that is the Kc, or to be specific, this is the acid dissociation constant, or we call it as the Ka. So if we have a stronger acid, the concentration of the H3O plus that is produced during the dissociation will be higher. It will make the Ka value become greater. However, if we have a weaker acid, okay, we will have a lower concentration of the H3O plus that is produced during the dissociation. Then we will have a smaller Ka value. So remember, the Ka value only present for a weak acid. Okay, because for the strong acid and strong base, okay, they are completely ionized. So the arrow is only forward arrow. This reaction is only occur in a forward direction. So we will have no Ka expression or Kc expression for this strong acid and strong base dissociation. So Ka and Kb. So for Kb, it is for base. Okay, only present if we have a weak acid and weak base because they are reversible reaction. Okay, so in this table, we have a list of the weak acid: chlorous, nitrous, HF, formic, acetic, propanoic, until hydrocyanic acid. Okay, so they are all weak acid. Okay, how do we know that they are weak acid? Because they have its acid dissociation constant, its Ka value. Okay, and then among weak acid, there will be one that is stronger than the others. There will be one that is weaker than the others. So when we look at to this Ka value, we know how strong they are, okay, or how much H3O plus that they can dissociate. And if it has a greater Ka value, for example, chlorous, it is 10 power of -2. Of course, that it is stronger than nitrous, which is 10 power of -4, and the weakest one among these acids is hydrocyanic acid because it has the smallest Ka value. Remember, okay, Ka is actually derived from the Kc expression, but since that this reaction specifically is the acid dissociation process, then we don't call it as a Kc. Okay, it is a Ka, and it stands for the acid dissociation constant.